Perpendicular and angle bisectors. Our objective is to apply theorems about perpendicular bisectors and angle bisectors. Who uses this? The suspension and steering lines of a parachute keep the skydiver centered under the parachute. Let's look at some vocabulary. Equidistant is the same distance from two or more points. The locus is a set of points that satisfies a given condition. Now let's look at a couple theorems. We have the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, if you have a point, so let's look at point X, and it is the perpendicular bisector, so we have the perpendicular bisector here of AB. We know that XA is going to be equal to XB. So XA and XB will be equal. The converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So, if we take our perpendicular bisector here, and we've got if AX and BX are equal, then we know that AY and BY are going to be congruent, as well as the fact that XY is going to be perpendicular to AB. Let's try a couple of examples. So find each measure. We have the perpendicular bisector, as it cuts this segment in half, and we have 7.3 is our WX. So we need to know what WY is. Well, if WX is 7.3, WY will also be 7.3. The converse, if, for example, AB and AC are congruent, and you have this line being perpendicular, you know that line L is cutting BC in half, meaning that if DC is 16, you know that BD will also be 16, which means that the total from B to C will be 32. Let's look at another example. This one's a little bit more challenging. We want to find the length of PR. Well, since we know that we have PS and QS are congruent, and we have a perpendicular bisector, that means that PR and QR have to be congruent. So let's set them equal to each other. So we have 2n plus 9 equals 7n minus 18. And now we can solve for n. So we have 9 equals 5, not 7, equals 5n minus 18. We can add 18 to both sides, which gives us 27 equals 5n. And then we can divide both sides by 5, which gives us 5.4. So, now we need to figure out what PR is. So we're going to plug this in. So we have 2 times 5.4, and then we're going to add 9, which gives us 19.8. Let's look at the distance and angle bisectors theorems. So we have an angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So we have angle APC, so APC is congruent to angle BPC. So these two angles are congruent. If they are congruent, then from the point, if you meet the lines, or the rays, perpendicularly, AC is going to be the same measure as BC. The converse of that states that if AC and BC are equal, and they meet at a perpendicular, that means that the two angles have to be congruent. So angle APC would be congruent to angle BPC. Let's apply it. So applying the angle bisector theorems. So we want to figure out what LM is. Well, since angle JKM is the same value as angle LKM, we know that JM and LM have to be the same measure. So therefore it has to be 12.8. Looking at the converse, we have two pieces that are 74, which means that the two angles have to be congruent. So if the measure of ABC, so this whole angle here is 112 degrees, it wants us to figure out what ABD is. So we just need to take half of that because they both need to be congruent. So if we take half of 112, we get 56 degrees. Let's try another example. We want to find the measure of TSU. Well, since we have our two segments here that are congruent from a point and meet the rays of our angle at a perpendicular, that means that these two angles have to be congruent. So let's set them equal to each other. We have 5z plus 23 equals 6z plus 14. So let's subtract 5z from both sides. So we have 23 equals z plus 14. We're going to subtract 14 from both sides, and that's going to leave us with the fact that z equals 9. We're not done yet. We want the measure of angle TSU. So we're going to substitute 9 in for z. So we have 5 times 9 plus 23, which will give us 68 degrees. Let's look at a parachute application. Each pair of suspension lines on a parachute are the same length and are equally spaced from the center of the equally spaced from the center of the chute. How do these keep the skydiver centered under the parachute? Well, since PQ has to be congruent to QR and we're meeting at a perpendicular, that means that we can use the converse of the perpendicular bisector theorem. So that's how you know. Let's try writing equations of bisectors in the coordinate plane. So write an equation in point-slope form for the perpendicular bisector of the segment, with endpoints A is at -1, 6 and B is at 3, 4. Okay, so step 1 is to graph it. And you'll see up on the right-hand side here that it has been graphed. Now, step 2, we want to find the midpoint of AB. So to find the midpoint of AB, we want to take the average of your x's and the average of the y's. So we will have -1 plus 3 divided by 2 and 6 plus 4 divided by 2. And when we do so, we end up with 1, 5. So our midpoint is 1, 5. Now we need to find the slope of the perpendicular bisector. So we first need to find the slope of AB, and then we need the opposite reciprocal, because we want it to be perpendicular. Okay, so let's find the slope of AB. So we have the change in y over the change in x, which gives us -2 over, hold up, sorry about that, I accidentally flipped the 3 and the 1 around. So it's 4 minus 6 over 3 minus -1, which would give us 4, which is -1/2. So if you want the perpendicular bisector of that, we want the opposite reciprocal. So opposite would mean that it's positive, and then we need to reciprocate it. So it's going to be 2 over 1. Or you can just say your slope is now going to be 2. So our last step is to simply write the equation. So we have our slope and we have our point. So we can write it in point slope form. So we have y minus 5 equals 2 times x minus 1. And you're done. Try this next one on your own. Now that you've had a moment to try it on your own, let's try it together. So we want to find the middle, so that way we can have the perpendicular bisector. So we want to be able to bisect it, so we need the midpoint. So we're going to take the average of our x's, so we're going to have 5 plus 1 divided by 2, and then we're going to have 2 plus negative 4 divided by 2, and that will bring us to 3, negative 1. And then we want to find our slope. So our slope is going to be the change in y over the change in x. So we have negative 4 minus 2 over 1 minus 5, which gives us negative 6 over negative 4, which then reduces to 3/2. So if we want the perpendicular of this, we want the opposite. So since it's a positive, we want the negative. And then you want the reciprocal, 2/3. So you have your midpoint, your opposite reciprocal slope. That's all you need. You need your midpoint, the opposite reciprocal slope. You need both of them, perpendicular, opposite reciprocal slope. Bisector, midpoint. You need the middle. Now you can put it all together in one end step. So we have y plus 1 equals our negative 2/3 times x minus 3. And that concludes our lesson on perpendicular and angle bisectors.